All right, DCA review part 2. Determine the distance between the 2 points. To determine the distance, you need to know what the distance formula is. And the distance formula will be on your formula chart, but if you forgot, it is equal to the square root of x minus x squared plus y minus y squared. Or you can use the Pythagorean theorem, but in order to use the Pythagorean theorem, you have to make it form a right triangle. Okay, so keep it as straight as possible, but it has to form a right triangle. So if you use Pythagorean, it would be c equal the square root of a squared plus b squared. So we're going to use Pythagorean, which can be a little simpler for many of you. First, you need to find this a and b. So a could be this leg, and that's 4 units. B could be this leg, which is 11 units. So that means it would equal the square root of 4 squared plus 11 squared. And we can do this without a calculator. And you might need to practice doing it without a calculator, because the DCA will be part calculator, part not. So 4 squared is 16. 11 squared is 121. And then you add 16 and 121, and you'll get 137. And without a calculator, this is as far as you could go. So leave your answer the square root of 137. Oh gosh, that's horrible. Box. Write a biconditional statement. A biconditional statement has the formula P if and only if Q. The key is to identify P and Q and then separate the two using if and only if. So in this first one, and I'll only do probably 1 or 2, you'll take this, everything after the word if before the comma is P. Everything after the word then before the period is Q. So to write it in as a biconditional, you would write today is Monday, if and only if tomorrow is Tuesday. Again, it reads today is Monday, if and only if tomorrow is Tuesday. And you do the same process for 2 and 3. On a side note, a biconditional will be true if it is true forwards and backwards. Again, a biconditional will be true if it is true forward and backwards. Alright, so today is Monday, if and only if tomorrow is Tuesday. That's true. Read it backwards. Tomorrow is Tuesday, if and only if today is Monday. That also is true. Let's read this one. If you are reading this, then you're in math class. That's true. Now read it backwards. Well, that could be false. If you're, well, that could be true. That will be true. But if you read it backwards, if you're in math class, then you are reading this. That's false because just because you're in math class doesn't mean you're reading. You could be not paying attention to your teacher at all. Number 3, if you are happy, then you had a good day. Most of the time that's true. If you read it backwards, if you had a good day, then you are happy. That could be false. People do express their emotions differently. So having a good day doesn't always make people happy. This one wants us to circle all of the angle pairs that can help prove lines parallel. I will highlight them. So corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles. All 4 of those can help prove lines parallel. The other 2 do not. Use the numbers below to establish a pattern and list the next 5. So 1 plus 2 would be 3. 3 plus 3 will be 6. 6 plus 4 will be 10. 10 plus 5 will be 15. 15 plus 6 is 21. 21 plus 7 is 28. So the next number you would add 8 and it would give you 36. Then you would add 9 and it would equal 45. Then you would add 10 and it would equal 55. Add 11, it'll equal 66. Add 12, it'll equal 78. So those would be the next 5 terms. Translate the given picture along the vector 0, 4, and then reflect in the y-axis. So whenever it's written in vector notation like it is here, and the number that is first will be the x movement. The number that is second is the y movement. Since x is 0, there will be no movement in regards to x. So in other words, no movement left or right. But since there's a positive 4 in place of y, that means you're going to go up 4 units. So each dot on this picture will move up 4 units. Okay, so here would be the new picture after you translate. Now you have to reflect over the y-axis. To reflect over the y-axis, you figure out how far from the y-axis is each dot. The dot at the very top is 5 units from the y-axis, so its reflection will also be 5 units. This next dot on the far left is 3 units, so its reflection will be 3 units. The one across from it is 7 units, so its reflection will also be 7 units. And then directly beneath this one, it is also 7 units, but 3 units. So right here. Sorry, it's up here. So this would be the final figure. So again, it translated 4 units up and reflects the y-axis. Describe the transformation from picture 2 to picture 3. So picture 2 is down here. If I pay attention to this bottom point on the bottom right or bottom left corner and follow its transformation. First it was down here, then it moves left. And it moves 2, 4, 6, 8, 10 units to the left. Then that same point moves up to locate here. And that it moved 2, 4, 6, sorry, 2, 4, 6, 7 units up. So to go from house 2 to house 3, we had a translation, 10 units left and 7 units up. Write the contrapositive of the following statements. Contrapositive means not Q, then not P. So this is P. Sorry, I said Q. This is P following the word if before the comma, and this is Q following then. If I look at both parts, neither one has a not in there already, so we must add the not and interchange them or switch them. So the contrapositive for statement 1 would say, if there are no tutorials, then it isn't after school. For the second one, it would say if 2x plus 4 does not equal 10, and notice how I put does not equal, I'm still using symbols, then x does not equal 3. So you can say does not equal in symbols. You don't have to always say it in words. The key is add not where it doesn't exist, take it out where it does, and switch. We're going to determine the validity. Validity means whether it's true or false. If it is false, we're going to provide a counterexample. If you are in Nimitz Senior High School, then you are a sophomore. That is false because you could be a junior, you could be a senior, you could be a teacher. It just says that you're in the school. So a number of different types of people or individuals could be in the school. Number 2, if A, B, and C are collinear, which means on the same line, then B is the midpoint. That is false as well, because you don't know for sure that B is between. So we don't know enough information. B could be off a little bit. C could be in the middle. We don't know. We don't have enough information. Is this an enlargement or reduction? P prime, remember, is the image or the new. P is the pre-image or the old. So to go from P to P prime, it definitely got bigger. So this is an enlargement. Find the value of x. Well, we know that x plus 25 is equal to 30. So x has to be 5. Now we're going to find the scale factor. To find the scale factor, you take new divided by old. So the new distance was 30. The old distance was 5. 30 divided by 5 is 6. So the scale factor is 6. In other words, you took 5 times 6 to get the new picture. Find the midpoint of the following points. The midpoint formula from your formula chart says x plus x divided by 2, comma, y plus y divided by 2. So for number 1, that means negative 4 plus 2 divided by 2, comma, negative 6 plus 6 divided by 2. Negative 4 plus 2 would give you a negative 2. Negative 6 plus 6 would give you a 0. And negative 2 divided by 2 would give you a negative 1. And 0 divided by negative 2 would be 0. So that would be the midpoint. Write it as an ordered pair. And C works the same way. You should get negative 3, negative 2. On this one, they tell you what the midpoint is, and D will be the midpoint. Our job is to figure out the missing point. So for the first one, the missing point is F. So what I would do is plot D and E first. So D is located at 0, 6, which is here. E is at negative 2, 4, which is here. Again, D is the midpoint. D is in the middle. So there's a pattern you should recognize between E and D right now. To get from E to D, you have to go up 2, over 2, to the right. So that would take the same pattern to get from D to F. Go up 2, over 2. So F would be here at 2, 8. Okay, let's do the same thing for number 2. F is at negative 5, 1 this time, which is up here. D is at negative 3, which is down here. Again, find the pattern to get from one to the other. D is always in the middle. So to go from F to D, you have to go down 4 and right 2. So to get from D to E, you would do the same thing. Down 4, right 2. So E would be at negative 1, negative 9. I'm sorry, negative 1, -7. Angle bisectors. The take-home piece is that an angle bisector is a line that splits an angle into two equal parts. So the angle bisector on this one is this line, this blue line in picture 4, PT. That's the angle bisector. The two angles, well, the bigger angle that was split is right here, Q. The bigger angle is QPR. That's the angle that was split into two. So it wants us to use this picture to answer the next few questions. Now QPT, which is this small angle here, I'm also going to call it 1, is equal to TPR, which is this smaller angle down here. I'm going to call that 2. So in other words, 1 equals 2. That is true, because I just mentioned that the line splits the bigger angle into two equal parts. Then RPT, which is number 2, is 1/2 of RPQ, which is the big one. That's true. TPR, number 2 again, is 2 times QPR, which is the big one. That would be false. QPR, which is 1, is the same thing as Q, is equal to QPR is the big one, is equal to QPT, which is 1. That's false. TPQ, which is 1, is equal to 1/2 of TPR, which is 2. That's false. And then RPQ, which is the big one, is equal to 2 times RPT, which I named 2. And that would be true. Now, perpendicular bisectors. What you need to know about them is that it bisects a segment into 2 equal parts. So splits segment into 2 equal parts. So this one's not finished yet, but if I were to draw the point of intersection on each of these arcs, and then draw a line that connects those 2 points of intersection, that line would be your perpendicular bisector. Perpendicular because it forms a right angle with segment AB. If I were to name the point where the bisector intersects AB, I would call it M, which means midpoint, because again, it cuts it directly in half. What I mean is the distance from A to M will equal the distance from M to B. So AM equals MB. Another way to show that is with tick marks. So you could have one little tick in between each piece to show that they are the same. But that's the purpose of a bisector, is to cut it into 2 equal parts. This concludes your DCA review.